All right, our next example is a three-beam balance. So a three-beam balance is like this. It's used for measuring mass. And the way it works is you put something up here on the measuring tray, and then these little riders slide along the three beams that are here, and each of the beams has different marks on them. So if we take a look at this section, that's what we're seeing right here. So there's a beam that contains tens of grams, hundreds of grams, and single grams with the smallest division, smallest graduation at the tenths of grams. Now the basic rule for figuring out the maximum capability is to find the smallest division, in this case tenths of grams, and then the maximum capability is one place value smaller than that. So the maximum capability here is in the hundredths of grams. All right, so let's go ahead and make our measurement, knowing that ultimately we want to record this out to the hundredths of grams. So it is no 100s and 20 tens, and then it is at least 7 ones, and then beyond that it looks like it is 7, and then 1, 2, 3, 4, 5, 6, 7 tenths. 7 tenths. And by the looks of it, it looks like it's right on that 7 tenths line to indicate that the estimate of where it is right on that line. We're going to write 7.70 grams. And that's the proper measurement with this measuring scale. On this triple beam balance, the maximum capability is in the 100th spot, so we record 27.7 and 0 hundredths of the way to the next line. Let's look at our very last example. All right, this is a graduated cylinder. This is used to measure volume. Graduated cylinders are a little bit different in that in the graduated cylinder, the water will actually make kind of a curved level as you pour it in. The water tends to climb up the sides a little bit. In order to properly read a graduated cylinder, you need to look right at the very bottom of that curved surface. That curved surface of the water is called a meniscus. All right, so let's take a look. Let me erase that here. Let's take a look at these two graduated cylinders. All right, what's the maximum capability? You could pause this and see if you can figure out the maximum capability. All right, well, the smallest lines here represent whole numbers, single place value of 1. These are tens, these are ones. The maximum capability will be one place value smaller than ones, or tenths. Okay, and this will be milliliters. Now let's look at the actual measurement. It looks like this line is right there. That looks to be 60. There's 61, 2, 3, 4, 5, 6, 66 point. And again, we're going to go out to the tenths place, and it looks like it's maybe about 3 tenths of the way to the next line. So 66.3 milliliters is the proper recording of this measurement to the maximum capability of that scale. Now let's try this one. Again, you figure out the maximum capability and the measurement, and we'll check if you're right. Okay, so maximum capability. These are tens, these are ones. We go one place value past the smallest line. Smallest line is the ones place, so we're going to go out to the tenths place again. Tenths place, and that'll be in milliliters. The measurement here, well, it looks like that bottom of that meniscus is right on that line. So it's 40, and then 1, 2, 3, 43. But now we have to show that the maximum capability of our ruler means we're not guessing about that 3 at all. And so we're very confident about that. So we say 43.0. That gets us out to the tenths place, which is the maximum capability. Now, there are plenty of examples in the reading, and we'll get plenty more practice in class. That's the end for now.